Okay, so here is where we're going to be looking at the code of how to create classes, um, subclasses, and inheritance. And before you started watching this, you need to make sure and watch the 5-minute video that I included with the analogy and the visuals of what is a class, a subclass, and inheritance. So if you haven't seen that, please watch that first. It's going to really be helpful. Here I'm just getting into the code, but you need to see the big picture, really understand the reason that we have classes. Okay, so creating a class at first will look like just like when we create a structure. So here we have a class called person, just like a structure that we had earlier in the previous chapter called person. It has a name constant. It has an initializer, and then it has a function that says hello. And here we say let person equal person name Jasmine. We print the name and we say hello. So this looks just like the structure that we had in the previous chapter, except we just changed the keyword called class. So with inheritance, what we have is, like you saw in the previous video, we have a superclass, and base classes inherit everything from the superclass. So they inherit everything that's in here can be inherited by a subclass. So if we have a base, let's say we have a superclass called bicycle, and then we have a base class called vehicle and a subclass called tandem bicycle. Both of these classes, so we have tandem bicycle that would inherit from bicycle and vehicle, and then we have bicycle inherits from vehicle. So these are both vehicles, and tandem bicycle is a bicycle. So let's just take a close look at vehicle. So vehicle has a property called current speed. So it gives us the vehicle speed and it gives us a description. The description just says you're traveling at whatever speed, miles per hour. It also has a function make noise, and it doesn't do anything here in the vehicle. So vehicle is our base class. We create vehicle, we call the function, we print out the description, and it says that we're traveling at 0 miles per hour. Okay, so nothing new here, looks just like our structures. Now, what we're going to do is we're going to create a subclass that inherits from vehicle. So we have, the way we define this is we have the new class that we're creating, the subclass, with a colon, and this is the class that we're going to inherit from. And it becomes a superclass because we're inheriting from that class. So vehicle is now just not going to be a class, but now it's going to be a superclass because we're creating bicycle, and bicycle is inheriting from vehicle. So bicycle class, all that we put inside bicycle class is var has basket equal false. That's it, just a variable. But this bicycle class has this, and it has this, and it has this. So it has all of these properties and functions that it inherited from vehicle. Okay, plus one more thing, we added the has basket. So let's take a look and see how we use bicycle class. So first of all, we say here's our class bicycle. we say let bicycle equals, and so here we initialize this variable called bicycle, not variable, excuse me, constant, and then we assign true to has basket. So this bicycle that we just created, this instance of the bicycle, has a basket, and we're going to assign true to that. Then we're going to change the current speed to 15 miles per hour. And remember, current speed is not here. You don't see it here, but it's been inherited from vehicle. So we can use anything in vehicle just like if it was in here. And again, description is in vehicle, and we're using it for bicycle. So now we say bicycle is traveling at 15 miles per hour. So this is called inheritance. And we use inheritance like in the previous video. It said when you have some code and you want to reuse that code over and over again because it can be used in other programs or instances, then you want to put it in a class and inherit, make other classes that inherit from it so you don't have to recreate the wheel. So here's another subclass. This subclass is called tandem. And tandem is inherited from bicycle. But remember that bicycle inherited from vehicle. So now this tandem has everything from bicycle. All that bicycle had was, all that we added was, it had a basket. And then all the other things that vehicle had. So for the tandem bike, we're adding one variable called current number of passengers. And then here we create an instance of tandem. We change has basket to true. We change number of passengers to 2. Current speed to 22 miles per hour. We print the description. Description says tandem traveling at 22 miles per hour. So all we added to this class was number of passengers. We inherited the property number of the has basket, and we inherited all these things from vehicle. So tandem has all of that. Okay. Then we have here overriding methods and properties. So you will inherit everything from this class that you put here, but you do have the ability to override and change the functions and properties of what you're inheriting. And all you have to do is write the word override in front of a function or a property that you want to override. So here we're overriding the function make noise. Remember make noise way back here. Let's go back and remember what make noise does. So remember that make noise in vehicle did what? It did nothing. There was nothing. So we called make noise and nothing would print out. This is in vehicle. Now, this class train is going to inherit all the properties from vehicle and is going to change what make noise does. So the function now, only when you call it for train, only when you make an instance of train will you print make noise, and then it will print choo-choo. So here we created an instance of train. That's what we call that when we create a variable or a constant of a type class. We call that an instance. So I'm creating an instance of train. I can create many instances of train. I can create 3 trains, 4 trains, and each train can have a different speed. But they're all going to print, if I print the noise for all the trains, they will print choo-choo. So train.make noise, and it will print choo-choo. Okay, so our superclass is vehicle, our subclass is train. Train is inheriting all the properties and functions from vehicle. Now we have another class called car. It's also a vehicle, so it inherits everything from vehicle. We're adding to this car, to this class, we're adding one variable. called gear. So cars have gears and trains don't, so we didn't put that in there. Not all vehicles have gears. And then, or maybe trains do, and I don't know if they do or not. And then we have override the variable description. So remember, description was in the vehicle class, and the description used to say going so many miles per hour. Well, now we're changing. Anytime we create an instance of a car, and when we call the description, or when we print the description property, it will print or return super.description plus in gear. So it's going to return this string. So super.description. So actually what it's doing is giving us the description of vehicle. So it is going to say going so many miles per hour, but it's also going to add the gear. So it's going to say, right now it's going to say 0 miles per hour plus, so it's going to say, I don't remember what it used to say. Let's see what it used to say. The description used to say traveling at 0 miles per hour. That's what vehicle said, description said. So going back to here, when we return, we're going to return going 0 miles per hour in gear 1. So here we create an instance of car. We call that instance car. We change the speed to 25 miles per hour. We change the gear to 3. We print car.description, and it's going to print car is traveling at 25 miles per hour in gear 3. So that's this description here. So notice super. Super refers to vehicle. That is your super class. Okay. Why is it a super class? Because we're inheriting from vehicle. So car is the base class, vehicle is a super class. And if you watch the previous video, all this should be making sense. We're just looking at the code that might be, it's what you'll need to sit down and practice with and try to understand. And I'll just say classes can be really, like, you have to just think really outside the box with classes. It can be a bit overwhelming for new programming students and difficult to understand. So make sure you look at the analogy that I provided before this. Okay, and we can also override the initializer when we inherit. So here we have a class called person with an initializer that just takes the name that we assign it, and initializes our name variable. And then here we have a class student. This is the class. This is the superclass. So we inherit, student inherits all the properties, functions, initializers, everything from person. So we've inherited all this from person. And we created a variable called favorite subject. And favorite subject is going to be a string. Here, if we were to run this, it would give us an error or warning that says class student has no initializer. So this student class has no initializer. So what we're going to do is we still have our variable here that we created for student. It's the student's favorite subject. We're going to create an initializer. And when we initialize student, we're going to pass it the name of the student, and his or her favorite subject. Self dot favorite subject equals favorite subject. But name is not here, so we can't do self dot name equals name. We have to say super. We got to go back up here, dot init name. So here we're initializing the name in the superclass. So if you have an initializer, you've got to initialize it in your subclass. If your superclass is an initializer, you need to also create an initializer in your base class. When you create an instance of a class, what does that mean? Well, let's show you an instance of a class. Just to remind you, this car is an instance of a class. I can have let car equals car, let car 1 equals car, let car 2 equals car. Now we have 3 instances of a class car. Okay, so those are instances. How many do I create? So this is saying when I create an instance of a class, Swift returns the address of that instance, okay, which is the address in memory where that instance of the class lives. The returned address is assigned to the variable. When you assign the address of an instance to multiple variables, each variable contains the same address. So if you update one instance, then all the variables refer to the updated instance. So let me see if I can give you an example of this because it can get really confusing. Let's say that I have the Serrano family, right? So my family, Serrano family, is the class, and I'm going to create an instance of the Serrano family. And we all have so the Serrano, if I create an instance, I have an address. Okay, so let's say that the address is my home. Okay, so think of me in my house. Okay, so Miss Serrano is in her house, and let's say that my address is 100 Main Street, Dallas. Okay, and then if I create an instance of Serrano family, let's say I create a child, I have a baby. Now that child is in my address, has my address. I create another child, my child has the same physical address, 100 Main Street. We all live, all the children that I create will all live on 100 Main Street. And so that's what it means. It means that we have the same address. So anything I do to the address, let's say that I change the color of my house, right? Then child number 1's house will be the same color that if I make it yellow, his house will be yellow. And then the second child, his house will be yellow. And the third child, his house will be yellow because we all live in the same address. That is what that is saying. So let's just look at that, what that looks like in code. So in code, if I create person and I create, here's the instance of Jack. Jack is a person, he's 24 years old. If I create another variable called my friend and I assign my friend Jack, then my friend is going to have the name Jack with the age 24. They live in the same address. So if I change Jack's age, then I'm also changing my friend's age. So Jack.age is going to be 25 because I'm adding 1 to age. My friend.age is also going to be 25. So if you do this, if you assign Jack to my friend, to a new variable, you're putting you're giving my friend, this variable, the address of this instance of the class, the address. You're not assigning it just the values, but you're giving it the address. So you're changing, you can mess up Jack if you change my friend. How that's different is in structures. That doesn't happen when you do that with structures, and you create Jack, the person, and you create a variable called my friend equal Jack. You're creating a separate complete structure. Okay, so now, like if we do the whole address thing, right? Jack lives at 100 Main Street, my friend lives at 200 Main Street or something. They're in separate locations. So whatever I do to Jack is not going to affect this friend here, who's also Jack with age 24. They're two different people, different in two different addresses. So when I say Jack.age plus 1, Jack age changes to 21, but this other person, my friend here, does not change. The age doesn't change. They're separate. And by the way, when we say the address, it's the address in memory, and the address is a hexadecimal number. It just finds an address where to store that information. When your program is running, the address is in memory. Eventually, if you store the information somewhere, then it's going to get stored, either a database or somewhere. But right now we're dealing with memory. All this stuff is happening memory when it's running. Member-wise initializers. Swift does not create member-wise initializers for classes. So we saw that common practice is for developers to create their own for their defined classes. So anytime you create a class, just create an initializer. How are you going to initialize the properties, those variables? For example, the variable name and age. So anytime you create a class with variables or constants, go ahead and create your initializer. Because it's not going to do it automatically for you like it did in structures. You need to always think, okay, I'm going to create a class, I'm going to create an initializer. And remember that there's many different ways you can create initializers. I think that we showed that in the structure in the previous section, before talking about classes. So when do you use a class versus a structure? So you got to ask yourself, am I going to reuse, is this code that I can use in other places? If it is code that you can use in other places, then think about creating a class so you can inherit from that class. Usually when you're working for a company and you're going to start creating a new program, these are things that are hashed out before people even start coding. When they're designing, there's a team of people. You say, okay, this is something that we should put in a class, and these are things, the designing process, you design everything down to what your variables are going to be called, what your classes are going to have, because then other people are going to need to use those and inherit from those. So here it says, go ahead and start it as a structure, change it to a class if you're working with a framework. When you want to refer to the same instance of a type in multiple places, or when you want to model inheritance. Okay? So this is the end of Unit 2, Lesson 4, Working with Classes. This is not a simple topic. Please take your time as you go through the exercises, and the main thing is to also, when you're looking at the exercises, is to understand the terminology, the word subclass, the word inheritance, the word superclass. And so when we look at the exercises, okay, I always had my folders here. I'm working with a new machine. And let's see where. This is my lab structure. Student resources. Classes and inheritance, lab. Open it. Okay. So for example, here it says create a spaceship class. So here's the name of your class, spaceship. Okay. So you would start here, you would start with your keyword class. It gives you the name, spaceship. Then it says that we want three variable properties. Okay, so we have var name, var health, var position. The default value of name should be an empty string, and health should be 0. Position will be represented by an integer, where negative numbers place the ship further to the left and positive numbers place the ship further to the right. The default value of position should be 0. Okay, so we're going to create our variables, and we have name. Name is going to be a string, empty string. Okay, so we're going to go over here. And then the first thing I want you to do is I want you to look at your book. Hopefully you've taken notes, and you can look at some class. Remember, let is your constants, var are your variables. Create, and then let's take a look at this first one. This is a better example for you to look at. Go back. Okay, here we go. Class vehicle. So this is what it means when it says the default value. So the default value means that you assign it a value. And remember, if you assign it 0.0, you don't have to say, or if you assign it a string, you don't have to say that it's a string or an integer. If you assign it just an integer, like a 5. So here we have var name, and our name, it says the default value should be an empty string. And then we have var health. The default value of name should be an empty string. Health should be 0. And then position, it's an integer where negative numbers, blah blah blah. The default value for position should be 0. Okay, so position equals 0. Okay, and then notice here it says, well, earlier, okay, so let's just run this. All right, so it said earlier, it said it didn't have an initializer. That's fine. I don't think it told us to do that, so we're going to leave it like that. But then here it tells us create a let constant called Falcon and assign it to an instance of spaceship. So let Falcon equal right, an instance of spaceship. So let Falcon equal spaceship. Okay. After initialization, set name to Falcon. Okay, so Falcon dot name equals Falcon. So I think what's difficult with these exercises is understanding what is it that they want me to do. So, I mean, definitely if you have reading comprehension issues, then you're going to need to maybe look at each one of these and separate them. So where it says create a let constant, just stop there, create the let, name it Falcon, assign, here's the equal assign, instance of spaceship, here's spaceship, Falcon is an instance of spaceship, set name to Falcon, set this variable name to Falcon. Let's go ahead and just print name. Oh, sorry, not just name, but Falcon.name. So when we print Falcon.name, we see that this name gets printed. Let's go ahead and print Falcon.health and Falcon.position. And so when we do that, we're going to see 0, 0. Health is 0 and position is 0 unless we change it, and we can. Then here it's going to ask us to go back and add a method called move left on the definition of spaceship. So any method that you add it inside here for the class spaceship. And this message should adjust the position of the spaceship to the left by 1. So you're going to subtract 1 from position. And if you go right, you're going to add 1 to position. Once this method exists, use them to move the Falcon to the left twice and to the right once. Print the new position of Falcon after each change in position. That's a lot of doing. So let's take a look. You go back and then say, okay, well, how do I create a method called move left that goes inside spaceship? So go back to your book, and so we're going to write function move right, and then in here you're going to add 1. If you move right, move left, you subtract 1. Think of the number line. To the right of 0 is positive, to the left of 0 is negative. As you do this, just remember that spelling matters. So if you misspell something, it's going to, if you misspell something, it will give you an error. And so just, it might tell you that it's undefined, and you're like, but I defined it. Look at the letters exactly and make sure that you spelled everything correctly. Position equals position plus 1. And then, so let's just test that out. Let's do one function at a time and make sure that it works. So we're going to say Falcon dot position. No, yeah, we already know Falcon position. We did it here with 0. So let's just go ahead and say Falcon dot move right. And I'm going to just press tab, and I see it here, and it does it for me. And then I'm going to print falcon dot position, because I want to see what it did. Oh, here's the perfect example. So it says use of unresolved identifier falcon, because I misspelled it. Did you mean falcon? Oh, see how smart it is? It even tells you that you misspelled it. So it's unresolved, doesn't know what it means because I typed it wrong. Okay. So I moved right. It calls this function, and I'm adding 1 to it, and it moved right. Remember that you can add it like this, or you can say plus equals 1, plus equals 1, like that. That is the same thing. This is the same thing as position equals. Just do whatever you feel comfortable with. Eventually you will hopefully use this. You can do minus equals 1, plus equals 1, time equals, division equals. And then you do the same thing for move left, except you're going to subtract 1 from position. Okay, so your book has some just really good examples. Just go back and try to get used to all the terminology. If you have questions, email me. When you email me, let's say you have questions about these exercises, just copy. So you're going to highlight, and you're going to press Command C. Command C will copy the text, paste that into an email, and send it to me and say, hey, I don't know. I looked at this and I have no idea what this means. Can you help me? And I'll be happy to give you the answer, to tell you how to do it. If you have an error, you can take a screenshot. So for example, let's say that you did this and you get this error here and you have no idea what the error means. If you give me a screenshot of this here, and make sure that you include everything. I need to see this here, pink on the side. I need to see the bottom also. All that will let me look at it and be able to help you debug. Okay? Good luck with the exercises. And if you're actually taking spring break, I hope you enjoy your spring break next week.